Hello, my name is Michaela DeForest, and I'm a developer here at the ATS Group and Galileo Suite. Welcome back to the third part of a three-part series on monitoring Kubernetes and cloud-native applications with Zabbix. In this part, we'll explore 3 use cases of parsing Prometheus metrics to monitor cloud-native applications, including the Kubernetes integration in Zabbix. So let's get started. I'll start with a quick introduction to the Prometheus data model format. Lines in the model begin with or without a pound sign. Lines beginning with a pound sign specify metadata that includes help text and type information. These lines are followed by additional lines where the first key is the metric name, with optional labels specified. These lines are followed by additional lines where the first key is the metric name, with optional labels specified, followed by the value, and optionally concluding with a timestamp. If a timestamp is not included, it's assumed that it is equal to the time of collection. Let's start with an example of this from the kubestate metrics endpoint that was installed in the first part of the series. Here's the output for the /metrics endpoint used by the Kubernetes integration. If I search for the text kube_job_created, you'll see help and type text followed by a line starting with the metric name, labels describing each job, and the time that it was created as the sample value. Now, if we go open Zabbix, we'll see an item called getStateMetrics. This item uses a script item type to get data from the /metrics endpoint. An example dependent item is the Kubernetes job count. So we'll go back to the items and select Kubernetes job count. This uses a Prometheus pattern as a pre-processing step to get the count of lines that have the metric name kube_job_created. And if we look at the latest data for this item, we'll see it's collecting a value of 91. So just to prove the result, I'll copy those lines that we found in the last step. So let me copy those lines, and then I'll paste them into a line counter, and you'll see that we get 91 lines here as well. So that Prometheus step was just counting the number of lines that have that metric name. Zabbix also offers quite a few templates for applications that expose Prometheus metrics. In this example, I've installed etcd in my cluster. etcd is a distributed key value store that Kubernetes itself uses, but in this case, we are installing a copy directly into the cluster to be used by other applications. In order to use the etcd template to monitor our deployment, we'll create a new host and call it etcd application. And let's add it to the applications host group. And attach the etcd by HTTP template. We'll also use the proxy that we have set up in our cluster before in order to reach the application via internal Kubernetes DNS. So this template requires us to add an agent interface that provides the location of the application API. If we look at the service for our etcd application by running kubectl get svc-a and pipe that to grep etcd, that's going to get all the services for all namespaces and then grep for etcd. And we'll see that we have a service called sample-etcd. It's in the same namespace as our proxy, so we can set the interface DNS to sample-etcd. So we're going to go back to Zabbix, and we're going to add an interface. an agent interface. It doesn't really matter what kind of interface, but we'll set it to an agent. And we're going to set the DNS name to sample-etcd like we saw in the service output. We'll connect to DNS. And the port here doesn't matter much because the etcd port is actually set in the macros, so we'll just leave that as the default. And just to take a look at the macros real quick, and we'll click on inherited and host macros, we'll see that there is this etcd.port, and it's set to 2379, which is the default and also what the service uses, so we can leave that as it is. Okay, so let's create that host, and we'll take a look at some of the items that got created. The get node metrics item is the master item that collects Prometheus metrics. So if we go and test this item, you'll see that it returns Prometheus formatted metrics. So this master item is going to create many dependent items that parse the Prometheus metrics. So if we go back to items and we choose this dependent item CPU, we're going to get the total user and system CPU time spent by adding the Prometheus pattern pre-processing step and setting the metric to process underscore CPU underscore seconds underscore total. And we want to get the value from that. While it's convenient when Zabbix has a template for the application for which you want to monitor, creating a new template for an application that exposes a /metrics endpoint but doesn't have an associated template with it is fairly easy. One of these applications is Argo CD, which has been installed in this demo cluster. Argo CD is the GitOps continuous delivery solution. Argo CD is a GitOps continuous delivery tool for Kubernetes. Each deployment in a Kubernetes cluster is represented as an application, and then Argo CD uses Git to keep applications in sync. Luckily, Argo CD exposes a Prometheus metrics endpoint that we can use to monitor the application. Documentation on the available metrics can be found on the Argo CD documentation site, and you'll find that this is the case for most other applications that expose this endpoint. Okay, so according to the documentation, the metrics server is available at the Argo CD-metrics service. So let's start by creating a new template for Argo CD. We're going to go to Configuration and Templates and then click on Create Template. Let's call this template Argo CD by HTTP. And we're adding it to the template/applications group. We'll add a macro called argo.metrics.service.port. And we're going to set this to the default port for Argo CD for the metrics endpoint as 8082. We'll also add a macro called argo.metrics.api.path. And we're going to set that to /metrics. So that's just the endpoint where /metrics is available. And then the last macro that we're going to add is argo.metrics.scheme. And this is going to be set to the default, which is HTTP. Okay, so let's add our first item that gathers the entire response of /metrics. This is kind of similar to what was done for the etcd template. So we're going to click on Create Item in the template, and we'll name this Get Application Metrics. And we're going to give it the HTTP agent type. Let's make the key argo cd.get_metrics. and give it a type of information of text. The URL we're going to use is going to use the macros that we created earlier. So we'll do argo.metrics.scheme : / and then we'll use the interface DNS, so that is available under the macro named host.conn, and then : and we'll put the port, which is argo.metrics.service.port, and then /metrics. Let's also set the history storage period to do not keep history. And we'll add that item. Okay, so now that we have our first item, let's create a new host to represent Argo. So we'll go to hosts and create host, and we'll name this Argo CD application. And we'll assign our new template that was just created called Argo CD by HTTP. We'll also add it to the applications host group. We need to define an interface like we did with etcd, so we'll add an agent interface, remove the IP address, and we'll set the DNS name to the name of our metrics service, which includes the namespace as well, because the Argo that's running in our instance or in our cluster is not in the same namespace as the proxy is. So that would be argo cd /metrics.argo cd. And we'll connect to DNS. And again, the port doesn't matter because we're going to set that in the macros. So let's have it be monitored by our Zabbix proxy so it can be reached. And the macros should not need to be updated. We're going to leave them as the defaults that we set. So let's click add and go into the host that we just created, where we can click on our item and we'll test this endpoint. So you're going to click test and then get value and test, leaving all the default macros the same. You'll see the Prometheus metrics that are returned, and that includes the one that we're looking for, which is argo cd _app info. So you'll see that's at the top here. And in this argo cd application deployment, we only have one application running. It's just an example application called guestbook. And it's being synced from this repository by Argo CD. So this metric collects the status of the applications that are in Argo. So let's create a discovery rule that collects all of the deployed applications. In this case, we'll only return one, but there could be many in another implementation of this. So let's go to discovery rules, and we're going to create a new discovery rule. So let's call this rule discover applications, and the type is going to be a dependent item because it depends on the metrics collection item that we created just a few seconds ago. And then you're going to select the master item to be the get application metrics item. And then you'll go to the pre-processing tab and add a new step called Prometheus to JSON, which is going to convert the application data to JSON. And then we'll set the parameters just to be the metric name argo cd _app _info to gather all the metrics with the same name. And then under LLD macros, you're going to add a name macro that is set to the JSON path $.labels.name, and then for namespace it should be .labels.namespace, And then for server, it should be .labels.dest_server. So we'll add that, and we're going to create 2 item prototypes. The first item prototype will be name, and we'll set that to the health, say that's the health status, set the item type to dependent item, and the item key can be argo cd.applications.health, and then the name, and the type of information will be character. Set the master item to be get application metrics, and then we'll go over to the pre-processing tab and add a Prometheus pattern pre-processing step that will be set to argo cd_app_info, and then we'll use the name as a filter, and then we'll use label to get the value of a label, and we'll set that to the label health_status. And then we'll add a second step to discard unchanged with heartbeat and set that to 2 hours. So we'll add that, and then we'll clone that one to create one for the sync status, which will be the same thing, but title it sync status. Change the key to argo cd.applications.sync. And then in the pre-processing step, set the Prometheus pattern label to be sync status. And we'll add that. And now when we go to latest data, we should start to see the sync and health status for each discovered application, which in this case, we just have one application called Guestbook. So in a few minutes, we should see the health and sync status show up. So we've shown how Zabbix templates such as the Kubernetes and etcd templates utilize Prometheus patterns to extract metrics data. And we've also shown how templates can be created for new applications that expose Prometheus data as well. We've also shown how templates can be created for our new applications that expose Prometheus data. Because of the adoption of Prometheus in Kubernetes and cloud-native applications, Zabbix benefits by being able to parse this data so that as you use the Kubernetes integration in Zabbix, you don't lose the monitoring of your applications within the cluster as well. Because of the adoption of Prometheus in Kubernetes and cloud-native applications, Zabbix benefits by being able to parse this data so that as you use that Kubernetes integration in Zabbix, you don't lose the monitoring of your applications within the cluster. I hope you've enjoyed this series on monitoring Kubernetes and cloud-native applications with Zabbix, and good luck on your monitoring journey as you learn to monitor with Zabbix in a containerized world.